Hello, my name is Nadia Kirstein and I work as a data scientist and hydraulic modeler in Envidane. And today I will talk to you about control of urban drainage systems. There are many benefits by using control to reduce the amount of combined sewer overflow in the system. For once, you don't have to construct anything new, you just use the capacity that's already there in a more clever way. Therefore, it's cheaper and emits way fewer greenhouse gas emissions than going for instance, sewer system separation or the construction of new basins. Control is also really quickly to implement, so you see the results rather quickly. But before you rush back to your utility and persuade them to implement control, I would advise you to take a step back and screen your system to see if there is at all a control potential. This whole methodology that I will tell you about today was developed in a research project with 6 Danish utilities. And in the beginning of the project, we asked the utilities if they thought they had a control potential in their system. And this is what they said. And this is what they actually had. So as you can see, some utilities guessed rather correctly, while other utilities were way off. It is therefore important to make an actual screening of the system to assess this before you just implement control. In this project, we wanted to create a methodology where you could not only assess the overflow reduction potential, but also enable the discussion on many other factors like cost and operation of the system afterwards that we also know is important for the choice of whether or not to go with control. But before diving into that, I will tell you a little bit about our methodology. So we use as our ground truth the hydraulic model, and we run that for a long time period, and then we post-processes these model results. In this post-processing, we look at each individual event in the time series from the hydraulic model results, and then for each event we go through the individual overflow locations. And for each location we see upstream if there's available storage, or downstream if there is available storage that we could have used to reduce this overflow locations. Once we've done that, we move on to the next overflow location and the next one and the next one before going to the next event and starting the analysis all over. Once we've gone through all the events, we have a full picture of the control potential in the system. The results are shown on maps, and this is where the dialogue comes into place, where you can see exactly which basin and exactly which actuators, meaning pumps and gates, you need to activate to obtain an overflow reduction in a specific point. That means that you can sit down with operators and planners and discuss how much would it cost to place a sensor here? Would it be difficult to operate this additional gate? How sensitive is the water recipient? How much overflow can be reduced, etc. You can do this with all the different overflow locations that we find in our methodology, and then you can choose the ones that are either where you save the most overflow or simply where it's easiest to start gain experience with control. I hope this short introduction made you curious. Please contact me if you want to hear more.